Hello everyone, I am Dr. R.V. Parimala, Professor and Head, Department of Electronics and Communication Engineering, Maharaja Institute of Technology, Mysuru. Here in this session, I will be explaining you about the basics of basic electronics. It will be studied either in first semester or second semester. The course title is Basic Electronics. The course code is BBEE103. Course type is theory. Teaching hours per week, it's actually divided into 4 parts: lecture, tutorial, practicals, S standing for project. But this course will have only the lecture hours. The credits reserved for this course is 3. In this video, I will be explaining you about the curriculum of basic electronics. Before we understand in detail the syllabus or the curriculum of basic electronics, let me take you through the title of each module there. There are 5 modules, and these 5 modules are focusing on semiconductor diodes, diode applications and Zener diode, bipolar junction transistor and field effect transistor, operational amplifier and operational amplifier applications, Boolean algebra, logic circuits and combinational logic, introduction to transducers and communication. Then let me take each module in detail. The first module, that is module 1, is on semiconductor diodes, diode applications, power supply and Zener diode. So when you talk about semiconductor diode, you will be introduced to the basics of semiconductor diode, starting with what is a conductor, what is an insulator and what is a semiconductor, and what is PN junction, what is P material, what is N material and what is PN junction diode, the characteristics of the PN junction diode and its parameters, that is input resistance and the output resistance, then diode approximations, DC load line analysis. So these are the things which you have already studied in PUC. The same thing you are going to repeat here to understand thoroughly exactly what is a PN junction diode and how exactly it is going to be used for the future applications. Then coming to the applications of diode, you will be using it as the rectifiers. Diode application mainly is on the rectification of signal. So it is used as half wave rectifier and full wave rectifier. So that is what is the thing you are going to study under diode applications. Then coming to power supply. Power supply is comprising basically on the full wave rectification diode, which is generally a bridge rectifier circuit followed by a filter circuit, and that followed by a voltage regulator. Zener circuit will be used as a voltage regulator. So now for the power supply, you have capacitor filter circuit and the RC representing resistance and the capacitor in pipe form. That is, the circuit will be rigged up in the letter pipe form. So for that circuit, how the power supply is going to be operated, that's what you are going to study under power supply. Then Zener diodes. So it's generally Zener breakdown voltage is the most important thing. That is where it is going to stabilize the voltage. So you are going to study about this junction breakdown circuit and the symbol of Zener diode, the characteristics, parameters of Zener diode, and you also are going to study about the equivalent circuit of it and its behavior as voltage regulator. That is the main thing you are going to study under module 1. So basics of diodes, its applications and how it is being used for power supply. Then coming to the second module, the next important component of electronic circuit is the transistor. It's a bijunction transistor or bipolar junction transistor. We will be introducing you to BJT voltage and the currents, that is BJT representing bipolar junction transistor. So amplification of BJT, common base characteristics, common emitter characteristics and common collector characteristics. A transistor will be consisting of three terminals: base, emitter and collector, depending on which is common to both input and output. We are going to classify them as common base, common collector and common emitter. So once that is done, you are going to study about the input output characteristics of all the three configurations, and also you are going to study about the transfer characteristics. That is what is the thing you are going to study there. Then how to bias a transistor for amplifier application, and what is the DC load line and the importance of DC load line, and where your biasing point should be on the DC load line. Everything you are going to study there under bipolar junction transistor. Then coming to field effect transistor, junction field effect transistor. Junction field effect transistor is called JFET, and MOSFET, enhancement MOSFETs, depletion enhancement MOSFET is metal oxide semiconductor FET. So that you are going to study under field effect transistor. So module 2 mainly focuses on the transistor and field effect transistor. So when you come to field effect transistor, for the transistor you will be knowing the three terminals as collector, base and emitter. For field effect transistor it is gate, source and drain. These are the three terminals, and based on that you are going to study the characteristics and its different parameters. That is under module 2. Coming to module 3, once again it is analog circuit, where you will be studying about operational amplifier and its application. So once we say operational amplifier, you will be studying about what is an operational amplifier. Is it a single stage amplifier or multi-stage amplifier? If it is a multi-stage amplifier, how many stages the amplifier is having, whether you are going to construct it using the discrete components, or is it available as an integrated circuit. Everything you are going to study under introduction part of it. Then what is the block diagram representation of typical operational amplifier, its schematic symbol, the parameters such as gain, input resistance, output resistance, common mode rejection ratio, slew rate, bandwidth, input offset voltage, input bias current and input offset current, etc. you are going to study as the parameters of operational amplifier. Then you are going to study what is an ideal operational amplifier and its characteristics. So once you know about that, then you are going to study about open loop configuration and the closed loop configuration. So under open loop configuration, you are going to discuss about something called gain, and for the closed loop configuration, how the gain is going to get reduced. And when you talk about the closed loop operation, there are two types of amplifiers which you are going to study basically, that is inverting and non-inverting amplifier. So then after, you will be focusing on the operational amplifier applications. So what are they? Inverting configuration, non-inverting configuration, differential configuration, and voltage follower, integrator, differentiator, adder, subtractor, etc. comes under operational amplifier applications. So using the integrated circuit, you are going to construct any mathematical circuit, any mathematical operation you can do it. That's why you have as an applicator here integrator, differentiator. You can also use it as a summer and subtractor, etc., adder or subtractor. Next, for the module 4, we are going to focus on the digital circuit. So digital electronic circuit. So under digital electronic circuit, the basic important thing that you have to study is about the Boolean algebra and the logic circuits. Logic circuits, you have already studied about that. It is OR gate, AND gate, and exclusive OR gate, NOR gate, and universal gates such as NOR and NAND gates. So using all those things, how to construct an adder, a subtractor, or any other kind of circuit, maybe a shift register, everything you are going to study once you know about the Boolean algebra. So Boolean algebra and logic circuits. So anything you start for a digital circuit should be starting with the number system. So when I talk about the number system, it will be having binary, octal, hexadecimal, decimal, etc. So here you are focusing on the number base conversion from octal to hexa, hexa to octal, octal to binary, binary to octal, and so on. So those are the things you are going to study there. Then complements, basic definitions you are going to study, axiomatic definition of Boolean algebra, basic theorems and properties of Boolean algebra. You are going to study Boolean functions, canonical and standard forms, other logic operations and digital logic gates. These are the things you are going to study under Boolean algebra and logic circuits. So then you have combinational logic. So introduction, design procedure, adders, half adder and full adder. So these are the things you are going to study under module 4. Then coming to module 5, it's about the transducers. Transducer is a device which converts energy in one form to the other form. So that is a transducer. So introduction to transducer, what is a transducer, what type of transducer we have it in nature. So such as resistive transducer, inductive transducers, capacitive transducer, thermal transducer, optoelectronic transducer, optocouplers. So they come under optoelectronic transducers, piezoelectric transducer, etc. You are going to study here, which is very interesting. How to convert energy in one form to the other form, you are going to study under transducers. Then finally a bit of communication you are going to study, that is introduction to communication, communication system and modulation, where you have two different types of modulation, amplitude modulation and frequency modulation. So after having completing this course, the students will be able to, that means once you complete a course, the expectation is from the student is that he should be able to do so and so. So what are those things? So they are classified as course outcomes, different course outcomes. So after studying that, what are the different course outcomes he is going to have it? So there are 4 course outcomes we have it. CO1, that is course outcome 1, CO2 course outcome 2, CO3 course outcome 3 and CO4 course outcome 4. Course outcome 1, it presents a comprehensive knowledge of semiconductor devices, electronic circuits, logic circuits, transducers and communication system. So it covers actually all the 5 modules whatever you have studied. So it says he should be able to comprehend about the semiconductor devices, transistors, Boolean expressions, that is logic circuits, also about the transducers and the communication systems. So that's CO1. Coming to CO2, he should be able to apply the knowledge of semiconductor physics, whatever is being done in your PU, or again you are going to study maybe in your UG course, that you should be able to apply here to illustrate the operation of electronic devices and circuits. Electronic devices and circuits, it's comprising of everything. Diode circuit, whatever you do it, that is rectifier circuit, full wave, bridge rectifier, half wave rectifier, anything you do it. Stabilizer circuit you do it, or you are going to talk about the operational amplifier circuit, everything is electronic device and circuits. So you should be in a position to apply the knowledge of semiconductor physics to analyze all this. Then apply the concepts of analog electronics to realize simple analog circuits and digital electronics to represent numbers in different forms, and simplify the Boolean expressions and also realize logic gates. So that you are going to do it after studying this particular course. Then finally you will be able to analyze the basic operation of various transducers. So once you look at the outcomes, it covers everything. That means after studying this particular course, you should have gained the knowledge to come out with all this. Then once we expose you to the detailed syllabus of electronics, basic electronics, then you should be also told about what are the books or the websites you have to refer to get the information. So that is why we call it as suggested learning resources. Under this you have the books, electronic devices and circuits, the title of the book, David Abel, author name, the 5th edition and Oxford publishers. Then you have the second book, Operational Amplifier and Linear Integrated Circuit. That's the title of the book. Ramakanth A. Gaikwad is the author. Pearson Education is the publishers, and it is the 4th edition. Digital Logic and Computer Design by Maurice Mano. So again, Maurice Mano is the author. Digital Logic and Computer Design is the title of the book. PHI Publishers, that is the publication there. Then it was published in the year 2008. Then Electronic Instrumentation and Measurements by David Abel. So again, Electronic Instrumentation and Measurement is the title of the book. David Abel is the author. Oxford University Press is the publisher, and it was published in the year 2013. Then Electronic Communication System is the title of the book. George Kennedy is the author name, and TMH, Tata McGraw-Hill Editions, that is Tata McGraw-Hill are the publishers, and it is the 4th edition book. Then there are few web links also provided here. So most of them are NPTEL links. So you can go through all the 3 to get the information. And why you have to study this? What is the importance of this? So electronics, you know that it is the leading edge of the world in the present time, and also the wave of the future. So every gadget, whatever you have it, including your mobile phone, maybe your washing machine, or maybe your television, or maybe your any other landline phone, anything and everything is having electronic circuit in that. So to know about that is very, very important as a technical person, and also as a non-technical person. It's very important to know what is the heart of each and every gadgets that we are going to use it. So that you need to study about that. The fundamental knowledge of this is very important for each and everybody. So this is the important course which is very important irrespective of whether you belong to computer science background or you belong to mechanical background or civil. You need to know about that. Once you complete the study, once you know the importance of this, the next thing is how the university is going to evaluate that. So evaluation process is divided into 2 parts. The first one is continuous internal evaluation. Throughout your semester, there will be having the assignments, maybe having your internal assessment test, like that. That is continuous internal evaluation. And then finally, after the completion of the course, semester end examination will be there. So semester end examination is SEE, CIE is continuous internal evaluation. Continuous internal evaluation is also divided into 2 parts. The first part is internal assessment test. There are 3 tests. Each test will be conducted for 20 marks. So there are 3 tests. So 20 plus 20 plus 20, totally it is 60 marks. Then you have the assignment part. It can be assignment, a project work, or maybe a quiz or anything. So for that 40 marks is reserved. So total marks, it's going to be 100 marks. So out of this 100, you have to score 40%. That means 40 out of 100. But this 100 mark is now descaled to 50. That is, it will be divided by 2. So downsized to 50. When it is downsized to 50, you have to score 40% out of 50. That means 20. If you score 20 minimum, you are eligible to write the examination. Otherwise, you will get NSSR. That means not satisfied sessional requirement. That means 3 tests of 20 marks each, and then 1 or 2 assignments. So together it is 100 marks. Out of 100, all those adding for 20 whatever you score. So for each 3 tests and 2 assignment, adding all the together, you should have scored 40 out of 100 or 20 out of 50. If not, if it is 10 out of 50 or something like that, you are not allowed to write the final examination. Then coming to the SEE, that is final examination, semester end examination. So for the semester end examination, it will be conducted at the end of your semester, and that at the end of your semester, it will be conducted for 100 marks. Since there are 5 modules, you get the questions from each module. There are 2 questions from each module, question 1 and question 2 under module 1. So each question is for 20 marks. You have to choose either 1 or 2. So like that, for module 2 it is 3 or 4. For module 3, 5 or 6, like that. So you have to select 5 questions out of 10 questions. Each question is for 20 marks. So total marks is going to be 100 marks. So again, the semester end examination marks is downsized to 50. Even here, for passing, it is 35%. 35% for 100. Then it is 18 for 50. So remember, think that you have scored 20 in continuous internal evaluation and 18 in the final examination. Together it is going to become 38. If it is 38, you are failed. Actually, to clear a paper, addition of CIE and SEE should be 40%. Though it is 35 marks or 18 to clear the paper in the final examination, but to clear the paper to go to the next semester, it should be 20 plus 20 or 22 plus 18 or 25 plus 18, anything it would be. But you should score total 40% from both CIE and SEE, but minimum for the final examination is 18. If it is 30 in the internal and 10 in the external, again you are failed. So you should have scored 18 in the final examination, 25 or 30 in internal, then it should be pass. So please be clear about that. So with that, I am coming to the end of this session. Thank you so much.